in the beginning, in the introductory lecture, that dynamics is divided up into two main branches, which is the kinematics and the kinetics. And in kinematics, you were just interested in the geometric aspects of motion, right? So that's why we've been only looking at the position, velocity, acceleration, and so on. And not for one moment did we discuss what was causing that motion. Now that is the domain of kinetics, which we're going to jump into today. And today we're going to start to look at the forces and then later on the moments which are causing a particular type of motion. Now, why, as you can imagine, this may be important is, so for example, if we already know that we need a particular type of motion, let's consider this example of a parachutist. अब इस parachutist के साथ human anatomy जो है या फिर जो human body है, it can only withstand some particular sort of accelerations that something lands and so on upon impact, right? So we, sorry, if you hear a little bit of background noise, there are people around my building and my house, which is why. So anyway, there's only a particular acceleration that a human body can withstand. So we already need to know कि कितनी velocity से उसने फिर zero पे आना है जब वो land कर रहा होगा. So in order to establish कि क्या velocity या क्या acceleration उस parachutist की allowed होनी है, we then need to know कि अच्छा okay, what should be the drag force that governs the motion of the parachutist to get us that velocity, right? और वो drag force फिर हमें बताएगी कि अच्छा अगर इतनी high है तो फिर parachute की क्या shape होनी चाहिए and so on and so forth, right? So there's this one example of where we might be interested in the force that's causing or is governing a particular type of motion. Then you can imagine that whenever we're lifting something, and then imagine that we're lifting it with, let's say, a particular acceleration. Then again, we need to know what tension should be in the cables right here, or what sort of motor power should there be to cause a particular type of motion. So that's my point is that kinetics is actually the next step from kinematics, and it's everywhere. Okay, so just a little, let's just lay down what our sort of path for this kinetics part of the course will be. So initially, we're just gonna revise the Newton's laws of motions, and we'll see how it's actually Newton's second law of motion, which is basically the fundamental principle involved in kinetics. And Newton's second law of motion is the equation of motion. Sorry, this should be the equation. And that Newton's second law of motion, which is the equation of motion, in different. So things which you're all already familiar with. So let's see how quickly we can move along. As always, remember, if you have any comments, please just leave them in the chat. Rahman, okay. आप अपने headphones उतार के try कीजिएगा. Hopefully it'll work that way. So please just leave the comments in the chat. And as I said, it's a little basic. So if I'm going too slowly, you need to tell me to pick up the pace. Okay. Right. So 3 laws of motion for Newton, proposed by Newton, that we're all aware of. So the first law states, as I think sabko yaad hoga, that if a body has no resultant force acting on it, then it stays in its state of rest or its state of constant velocity. Okay, so this is the case when you have a resultant force acting on the body which is equal to 0. Okay, so this was the case of equilibrium, right? And that's why we've been considering it all over in statics. So note that this first law and the equation that I've written right here, that summation of F is equals to 0, is also known as the equation of equilibrium, right? This is the equation of equilibrium. So there are many ways to refer to the same thing, but this is basically the first law of motion. And the second law deals with the case when you actually have a resultant force acting on a particle. And in this instance, Newton's law tells us that the acceleration will be directly proportional to the resultant force acting on the body. And it turns out that the constant of proportionality is actually related to the mass of the body, such that if I write this law out, that is actually equal to summation of F is equals to MA. I think you're all familiar with this. Now, this is the case which we're discussing in dynamics, in this course, dynamics, sorry. So yes, so we've already discussed these things in the introductory lecture. Right, now this equation right here, summation F is equals to MA, is known as the equation of motion, right? The statics one was the equation, the first law was the equation of equilibrium. The second law is the equation of motion, as you can imagine, because this is governing the motion of a body. Finally, there's also the third law, which states that to every action, there's an equal and opposite reaction. That's how I remember it. So that's just the case when we have two bodies interacting or two particles interacting, then they both will exert forces on each other, which are equal in magnitude but opposite in direction. And they will be collinear as well. That's also important. Perfect. So things that you're all familiar with. Now, this second law that I've already written out, that F is equals to MA, where F is the, let's say, the resultant force. Let me call that FR. This is, of course, going to be our backbone for the next few weeks, actually. So let's see how we progress with this. So here, let me just point out that FR is the resultant force. A is the acceleration of the particle, and M is just the scalar mass of the particle. Okay? Yes. And another important thing to point out that Newton's law is actually it's called a law, but it's not actually applicable universally. So it's not really a law, is the point, but it is applicable for about 95% of the problems that humans encounter. Which is why it's still carried on to be used, right? So Newton's law is only applicable when something something has a velocity or a speed which is very small as compared to the speed of light. So when something starts to approach the speed of light, then Newton's laws start to break down. Okay. And then also, if the size of the particle is very small, that is, m is extremely small, then also Newton's laws start to break down. So when something starts to approach the speed of light, we start to go into the energy mass balance, which Einstein postulated. So E is equals to mc squared issues. Whereas here, when the size of the particle is extremely small, then we start to go into the realm of mechanics. Whereas Newton's laws of motions lie squarely in classical mechanics, okay? Which in our course, we're just going to be discussing this. Please do talk to your physicist friends to discuss with them what happens in quantum mechanics and so on. Whereas we're just going to stick to the same old basics right here. Perfect.
Ma'am,
जी please.
मैम स्पीड ऑफ लाइट से हम ज्यादा मूव क्यों नहीं कर सकते?
एक तो के with all my answers to these things, I will start with a disclaimer कि I am not a physicist और मेरा उतना ही knowledge है जितना आप लोगों का है, which is just generally पढ़ना लिखना है इधर उधर physics के बारे में. From what I understand कि basically if you start to move at the speed of light, then the sort of the conservation is no longer just the conservation of mass, it's the conservation of mass and energy. So things can start converting into energy basically. So इसलिए I guess आपको वो बेहतर पता है तो बताइए please. I don't know actually. I should say that. I'll look it up.
Excuse me, ma'am. मैम बेसिकली जो मैंने जितना पढ़ा था उसमें ये था कि जब आप स्पीड ऑफ लाइट से अप्रोच करते हैं ना तो आपको जो वो मैथ जो है वो इन्फिनिटी को अप्रोच कर लेता है. तो अब F इक्वल्स टू ma का फॉर्मूला है ना, तो जब मैथ इन्फिनिटी को अप्रोच करेगा तो इन्फिनिट फोर्स रिक्वायर होगी.
बिल्कुल ठीक है. अच्छा, when something
और इन्फिनिट
जी प्लीज।
yes मैम। और फिर जो इन्फिनिट फोर्स है वो एग्जिस्ट नहीं करती। तो
वेरी गुड,
इस वजह से कोई भी ऑब्जेक्ट जो है वो स्पीड ऑफ लाइट से ज़्यादा नहीं
very
जा
good, very
सकता।
good. So just one question though, when we do go to the speed of light, why does our mass become infinity?
मैम ये इक्वेशन है वो उसी आइंस्टाइन की थ्योरी से डिराइव होती है।
कौन सी?
आई थिंक आई हैव स्टडीड इन द ME114। आई डोंट रिमेम्बर इट नाउ।
अच्छा, okay, okay. चलें, okay. So there's one suggestion by thank you very much. So someone is suggesting that when we travel at the speed of light, our mass goes to infinity. I'm not. ये I would say again कि हम सबको ये चीजें भूली हुई हैं. So if somebody is very interested in it, you should probably look it up again. क्योंकि हमारा सबका थोड़ा सा इसके बारे में knowledge would have become a little bit shady, right? That's just my assumption about physics, जो थोड़ी ज़्यादा specialized हो. Right, thank you. Okay, apologies, but let's still move on. Mass increases with speed. मुंजर ने equation भी भेज दी. Okay जी, ये क्या है? According to Einstein,
ये ये M नॉट है। मैं
हाँ जी
उस
मुंजर, m naught उसका mass होगा, let's say at something when
एट रेस्ट।
at rest. Yes, exactly.
और व्हेन वी अप्रोचेस टू सी, तो ये टर्म जो है डिनोमिनेटर वाली ये जीरो होगी। जब ये जीरो से कोई भी चीज़ फिर डिवाइड हो तो जाहिर है वो इन्फिनिटी हो
ठीक है,
जाती है।
ठीक है। मुझे वैसे बताइएगा क्यों mass क्यों डिपेंडेंट ऑन वेलोसिटी है? Why?
मैम ये आइंस्टाइन की थ्योरी ऑफ रिलेटिविटी है, क्योंकि उसमें वो बेसिकली न्यूटोनियन और आइंस्टाइन की थ्योरी में फर्क यही है कि न्यूटन कहता है ये सारी चीजों का जो बेसिकली हम लेते हैं फील्ड ऑफ व्यू वो डिफरेंट होता है, और जो आइंस्टाइन कहता है ये आपका जो फील्ड है वो डिपेंड करता है आपकी वेलोसिटी के ऊपर।
फ्रेम ऑफ रेफरेंस आई थिंक नुमान है ना?
फ्रेम ऑफ रेफरेंस, यस मैम, मैं वो वर्ड नहीं याद आ रहा था।
नहीं नहीं बिल्कुल ठीक है। हाँ लेकिन ये सब बिल्कुल ठीक है और हम सबको पता है कि ये सारा का सारा चक्कर ही रिलेटिविटी के अंदर ही दिस इज ऑल डिस्कस्ड, बट आई जस्ट मेंट कि उसकी अंडरस्टैंडिंग इज अ लिटिल दैट एलूड्स मी राइट नाउ कि व्हाई डज द mass of a body, why would it depend on how you're observing it? But we'll again, sorry, लेकिन सब लोग अपने अपने टाइम में इसको देखें और आप लोग आपस में डिस्कस कीजिएगा और मुझे एट द एंड ऑफ अवर क्लास कोई प्लीज 5 मिनट लेके ना बताइएगा जरा सब कुछ के बारे में. I'm sure, yeah, I also had that moment in my life when you encounter relativity for the first time and then you spend like 2 days crazy searching about it or reading about it. लेकिन फिर you start to forget here and there as things move on, right? Chale. So thank you very much. That certainly that aspect of physics is certainly much more interesting in classical mechanics. But luckily for us, we are going to stay in classical mechanics because it is obviously significantly easier to apply, right? So staying within that domain, Newton also proposed, in addition to his laws of motion, I think famously there was an apple that fell on his tree, and from where he started to think about gravity, essentially. So he also proposed the law of gravitational attraction, where he proposed that two masses have this attractive force between them because of their mass, and he called this attraction gravitational attraction, and he gave this expression for the gravitational attraction like so. So it's the attractive force is a function of this constant g, and then the product of the masses divided by the squared of the distance between them, right? So I apologize, but I don't really remember how he derived the expression that he did, because this is actually pretty accurate for a vast majority of, at least for large masses, for sure, right? Whereas again, it does start to break down for small masses and the likes. So this was still pretty accurate, but then later on, about I think Newton was around in the 1600s, and then 16 to 1700s, and then Einstein came 200-300 years later, and then his theory of relativity actually explained why there is gravity, why gravity exists, right? With the whole space-time taken as 4 dimensions together and so on. Right. So if we think about this, then using this Newton's law of gravitational attraction, we can actually find what the attractive force will be acting on each of us, let's say due to the Earth's mass, right? So in order to do that, all I need to do is substitute in these expression the mass of the Earth and the radius of the Earth's surface, such that I get the force that's acting on me due to Earth, which is more commonly known as the weight, right? So my weight will then be given by my mass, which is the m2, so m times g, where now this g is a constant, which is coming from combining these 3 terms together, right? And now this small g is known as the, I think I have this right here, apologies. This small g is known as the acceleration due to gravity. Now, as we've just discussed, weight is actually the gravitational force of attraction between us and any large planetary object. So it's important to understand that this weight will change, or it depends on what the value of g is. So for example, it depends on how high along, so what my altitude is on Earth, number one. Number two, it also depends on which planet I'm on. So this is not something which is a constant, it's a derived property. Whereas my mass, which is a sort of a measure of how much matter I have, and in other words, actually using Newton's second law, it tends to be defined as, because it's the constant of proportionality relating the resultant force and the acceleration, it is also used to measure how a body resists changes in its motion. So that is how much force needs to be applied to get a particular acceleration. So it's in other words, it's some measure of its resistance to changing its motion, its state of motion, essentially. So this property mass is an absolute property. It is an intrinsic property of a body. It doesn't matter whether I'm on Earth or I'm on the moon. My mass will stay the same. Yes, so that's about it. Normally, when we're talking about my weight is 80 kg or so on, that's actually technically incorrect, right? We're talking about the mass. So mass is in kgs, and then the weight is in newtons, as it is a force, right? So just clarifying again, the system of units used. Mass is a base unit, as we just said, and weight is a derived property. So the base unit of mass is kilograms, kg, and weight is then a derived unit of newtons. If I just use the expression right here, W is equals to mg or F is equals to ma, I can figure out what the base units, which base units and in what power make up the Newton unit, right? By just using dimensional consistency, such that the units must balance on both sides. So Newton then is equals to kg for mass, and then the acceleration is of course meters per second square. So the derived unit Newton actually has within it these base units, and in this sort of power. Of course, kg, meters, and seconds are used in the SI system. We do have other systems used in the world still. For example, in the US, the foot-pound system is used pretty frequently still, unfortunately. Now, in the foot-pound system, the weight is measured in pounds. So the weight is considered to be the base unit, basically, or the force is considered, it's not the base unit, but it's considered to be the foundation of the system. whereas the mass then is measured in something called slugs. What a weird name. Anyway, and the gravitational constant would then be measured in feet and seconds, so feet per second square, and this is, it has a value that it takes this. Whereas a familiar one for G in SI units is equals to 9.81 meters per second square. Whereas in the FPS system, it takes this value, right? So all straightforward things as I've just said. One thing that I forgot to mention right here, which is that Newton's laws of motion, Newton came up with them just by observing nature. Okay, so what that means is that he actually applied known forces to known masses and measured their acceleration and saw that there was actually a linear relationship between them. Okay, so he derived this law experimentally, not by using some sort of a first principles analysis of the nature of matter or something like that, but just by observing things, observing phenomena. So that's why this sort of when you observe phenomena, something is also known as, something is phenomenologically derived. Phenomenologically. The spelling may not be correct, apologies. But it is phenomenologically derived, okay? It's experimentally derived and it's not a first principle based derivation. So we've already discussed what mass is. It's a measure of the resistance of a body to change its state of motion. In other words, it's also the measure of the inertia of the object. I think you're all familiar with inertia, so I don't really need to explain that in further detail. We've discussed weight, and we've just discussed the second law of Newton being the fundamental aspect of kinetics in dynamics, right? So let's jump into the second law of motion in a little bit more detail. So as we've seen, this is the expression for the second law of motion, also known as the equation of motion, as I've already told you. Please note here that each of the F and the A here are vectors. So when I say summation of F, I mean a vector summation, right? मतलब ये कि उनके individual X component and Y components will have to add together. Yes, so just be careful about vector addition. Right, so often the way we represent the second law or the equation of motion is, at first we consider its left-hand side and we draw out all of the forces, because we're going to consider a summation of the forces. So we draw out all of the forces acting on the particle. So something like this. If this particle had F1 and F2 acting on it, I'll just draw both of them together, right? And then I can use either just algebraic vector addition, or I can use the head to tail rule and graphically add them together. So this is F2 plus F1 to get the resultant force Fr. And now this diagram, which shows all of the forces acting on the particle, is known as the free body diagram of the particle, right? So that's how we represent the left-hand side. But then to represent the right-hand side, the MA part, then we draw out something known as the kinetic diagram. And the kinetic diagram basically just has one arrow on the particle acting in the direction of the resultant force, but actually represented as MA. Okay, so please note that the free body diagram, when you're showing the resultant force, is actually directly equivalent to the kinetic diagram, because the resultant force is equals to MA. The only reason the kinetic diagram sometimes exists separately is because often on the free body diagram, we may not show the resultant force. We may just be showing all of the forces acting on the particle. And on the kinetic diagram, then we can represent the resultant force in terms of MA. Perfect. Now let's come to, we already had started discussing this a little bit, which was talking about the frame of reference and discussing how हम तो वो relativity और classical mechanics के sense में कर रहे थे, so we're still going to keep it a little basic, our discussion. which is again that Newton's laws of motion, and in particular this equation of motion, that summation F is equals to ma, is only applicable when the motion of a body or particle is being viewed from an inertial frame of reference. Now, what is the inertial frame of reference? This basically means कि वो जो observer है हमारा अपना, the observer who's looking at something's motion, that itself does not, that observer does not have any acceleration. That is, agar the observer या फिर the frame of reference is at rest, so either it's at rest, either it's fixed, or it's only translating, it's moving with a constant velocity. Only then will it have no acceleration. And the reason why that's important is because agar ek frame of reference ki apni acceleration ho, right? So for example, if I'm accelerating, let's say, and then I view something which is at rest, then because of my acceleration, I will observe कि वो something which was actually at rest will look like it's accelerating to me, which is not really, which is not true, basically. So that's why we must, this classical mechanics, all of it applies when we're using an inertial frame of reference. Over here, only because अभी हम वो again वो physics वाली side पे नहीं जा रहे कि वो mass कैसे change हो रहा होगा उस body का and so on. We're just concerned कि acceleration की true value हमारे पास आ रही हो. इसकी वजह से we need the inertial frame of reference. Right? And then the beauty of these inertial frames of reference would be okay, then it doesn't matter so long as I have a frame of reference which is not accelerating, then I can use any frame of reference which is inertial and I'll measure the same value of acceleration. Perfect. So just note here that when I say that Newtonian or inertial frame of reference does not have any acceleration, that can only imply कि या तो वो rest पे है या फिर it's translating with a constant velocity. That is, it cannot be rotating at all. Why? Because rotation का तो आपको वैसे ही पता है कि the acceleration expression for, let's say, in curvilinear motion is, अगर मैं क्या है वो NT coordinates में लिखूं, then it's v dot u tangential plus v squared divided by rho tangential, normal, right? So my point is, for the rotational or curvilinear case, even if the velocity, the speed is constant, that is, this is 0, then there will still be a change in direction which will be causing an acceleration. That is, a rotating body is always going to be undergoing acceleration, no matter whether its speed is constant or not. Right? So inertial frame jo hai, it must have zero acceleration, which is why it cannot be rotating. Perfect. So how do we choose our frames of reference? Normally, when we're looking at things on Earth, then we get a little sneaky and we choose the frame of reference to be the Earth's surface. Now, even though I know and you know that the Earth is rotating, but we assume that the rotation of the Earth is actually at such a small acceleration that we can ignore it. So that's why we just assume that Earth is the inertial frame of reference. However, when we're looking at other particles or other, let's say, planetary bodies even, which are accelerating at the similar magnitude as Earth, then we need to look at something else, right? So then for sort of space-related motion, we actually consider the inertial frame of reference to be fixed at some far away star, because we assume that un stars ki acceleration negligible hai. Even though, again, I know that's not true. It's just an assumption, right? I know that the universe is expanding and they will have some acceleration, but we just assume that they're so far away, which is why we can consider their positions to be just at infinity and fixed. Right. Okay, so once we've got all of that set up, then yes, then let's start to move on to slightly more, again, classical mechanics things. I promise just a few more minutes and then we'll jump to some problems, and you'll all get to polish up your own skills for kinetic analysis. Sorry, let me just get a sip of water. Okay, yes. So, abhi tak we've just been talking about a particle, right? Now, this equation of motion we can also apply to a system of particles. Consider all of these systems existing like so. And then what I'm going to do, I'm just going to isolate one of the particles for now. Sorry. So if I just look at this one small particle I, then I can draw out its free body diagram and its kinetic diagram, noting that this particle actually has external forces acting on it. So let's consider that the sum of the external forces is capital Fi, and internal forces acting on it, which are these small Fi, internal forces. Such that now the equation of motion when applied to this particle, just this particle, would then become the summation of the external and internal forces would give me the acceleration of this particle, right? Straightforward. Now when I have, let's say, n particles, then I can write down n equations of motion for each of the particles. And then they're just straightforward linear equations, right? I can, if I want to, I can add them together for the entire system, for all of the particles. Such that when I add them together, what I get is I get a summation of all of the external forces plus the summation of all of the internal forces plus the summation of the product of the mass times acceleration for each of the individual particles. Now comes the interesting bit, which is कि ये जो internal forces थी, ये तो they come in pairs, right? They come in pairs. So if there's an internal force Fi acting on this particle, let's say because of another particle right here, then on this second particle there will be an equal and opposite Fi acting, right? So my point being that all of these internal forces actually balance out and they sum to 0, such that the equation of motion for the system of particles just ends up with having within it the summation of only the external forces. Okay? All of the internal forces, they balance out and they disappear. Okay. So it's actually just the external forces which govern the motion of the entire system. Perfect. If I want to, I hope this is clear. If I want to, I could even represent the right-hand side of this equation in terms of, let's say, rather than the summation of the product of mass and acceleration, in terms of the summation of the mass and the acceleration of one point within the system, which we frequently do, as you might recall. And what I can do is I can represent the total mass multiplied by the acceleration of just the center of mass of all the particles. So that it's just, I'm representing the entire system with the total mass and acceleration taken at one particular point to make my life a little bit easier. Now, the reason why this system of particles analysis is important is because you might notice that abhi tak to we've been talking about particles throughout, right? Like, and eventually, in about the middle of the course, we're going to start to move to talk about bodies. Okay? That is, bodies which have some discrete size. They have some size. They're not of negligible size and so on. Then in that case, bodies are made up of a system of particles. Okay. So by setting this up, we're already starting to discuss how the equation of motion might be applied to bodies, and we just noticed that internal forces, they disappear, they cancel out. It's only the external forces which dominate the acceleration of the entire system. Perfect. Okay. So
मैम
जी
मैम अगर तबीयत खराब है तो आधा लेक्चर बाद में ले सकते हैं.
थैंक यू सो मच. लेकिन नहीं मैं आई एम फीलिंग गुड. सिर्फ खांसी हो रही है, लेकिन अदरवाइज आई एम गुड. So kind of you to think of me. लेकिन नहीं अभी जब ब्रेक आएगी तो मैं कोई वो क्या होता है तूत से और उस तरह की चीजें कोई जल्दी से गरारे करके उसके बाद I'll be back. Don't worry. Okay. So yes, so we've got our second law of motion covered generally, but now let's jump to projecting it onto a coordinate system and then looking at it in the xy coordinate. आज मैं सिर्फ तेज से चल रही हूँ क्योंकि सिंपल चीजें इसलिए हम जल्दी अभी कर लेंगे. Now, if I'm using my rectangular coordinates, then of course I'm talking about my Cartesian frame of reference, so x, y, z frame of reference. Sorry, x, y, z coordinate system. Then that means that each of my resultant force, that is, each of my forces that are acting on the particle will have x components, y components, and z components. And all I need to find summation f, the vector sum of f, is to add together their individual respective I, j, and k components. ऐसा ही है. तो सारी forces के x component को add कर दूं, सारी forces के j components को add कर दूं, and then सारी k components को add कर दूं. Similarly, I can also break down or consider the components of the acceleration in the x, y, and z direction, such that now when I'm looking at this vector equation, all I get is that only the forces in the x direction will be influencing the acceleration in the x direction. Only the forces in the y direction will be influencing the acceleration in the y direction, and so on. Right? मतलब ये है कि इस वेक्टर इक्वेशन में से मेरे पास 3 स्केलर इक्वेशंस आ जाती हैं. Right? Perfect. So I can perform the analysis as I had been doing previously in my kinematics, which is कि जब मुझे position vector से velocity निकालनी होती थी rectangular components में, then I was just differentiating each of the components to find कि उनका ij, velocity का ij के component क्या होगा. और इसी तरह even for acceleration, वो double derivative each x का अलग से हो रहा था, y का अलग से हो रहा था, z का अलग से हो रहा था, with no dependence of them on each other. So इसी तरह I can carry on with in my kinetic second law of motion या फिर equation of motion के अंदर भी I can apply the same sort of scalar breakdown of my vector equation. Okay, so let's see what the procedure for the application is. What time is it? Still time. So we set up initially some inertial coordinate system. So often whenever we're talking about motion on Earth, then we'll just use the Earth as the inertial frame of reference. And then right now, abhi hum rectangular coordinates ki baat kar rahe hain, isliye we'll just set up a rectangular coordinate system. Then we draw the free body diagram to show all external forces. ये भी हमने discuss किया है, right? Acting on the system or acting on the particle. Then from the free body diagram, we can sort of resolve the individual forces to find what the resultant force will be. And then from the resultant force, we can draw the kinetic diagram, such that only the MA is represented, ताकि वो clearly नजर आ जाता है फिर kinetic diagram से. Finally, I can then apply my equation of motion, ये वाली, to find के let's say अगर force known है, resultant force known है, तो acceleration क्या होगी, या फिर अगर acceleration known है तो फिर क्या force required है. please notice here that in all of this we've just been talking about forces and accelerations, लेकिन sometimes we may actually not have the acceleration directly, या फिर we may need the velocity and position such that अगर हमें उन geometric properties में जाना शुरू करना होगा, then we need to jump back to our kinematic analysis that we now already know how to do. Okay, so just a few more comments before I take a break. Just one more one. So that's something that I've already just said, which is free body diagram, you only have the external forces. So please be careful about this. When we're talking about a system, only external forces. When we're talking about a particle, then उसके ऊपर जो जितनी भी forces हैं वो आनी शुरू हो जाएंगी. Okay. Yes, or again, what type of forces? You could have the external forces act कर रही हो, they could be the weight, normal forces, friction, and applied forces, and so on, right? So इसके अंदर, if you have friction, then be careful that friction always acts to oppose motion, right? So friction की direction must always be opposite to the direction of motion. Secondly, in the applied forces, you could have, let's say, a spring system that you're considering. Then spring force ko mat bhulega कि that is actually equal to K times delta L, right? So if there's a delta L is positive, then it's a tensile force. मतलब ये कि अगर spring में extension हो रही है, then it's tensile. Whereas if there's compression in the spring, delta L is negative, then it's a compressive force. Okay. So be careful about these. The equation of motion, as we've already discussed, is actually an equation of motion because it's a vector equation, and we can break it down into each of its scalar component forms. So if we are in the rectangular coordinates, that means we get an equation each for x, for y, and for z. Okay. Yes, and then finally, the kinetics or the equation of motion only relates forces and accelerations. अगर हमें velocity चाहिए, then we need to go back to our kinematic analysis जो हमने previously consider किया है. That is, you remember मैंने एक sort of set of results लिखे हुए हैं यहाँ पे for the kinematic sort of analysis. Okay? So all of that we need to still carry with us, that baggage, because interplay between kinematics and then jumping to कि अच्छा अगर ये velocity हमें profile given है तो उसको cause करने के लिए क्या force चाहिए होगी. तो पहले हमें kinematic analysis use करके we'll have to go from the velocity to the acceleration, then use kinetics to go from acceleration to the forces. Perfect. So with that, I'm going to take a break and then we'll come back to do some examples for kinetics, basically in the XY coordinate system. So it's 9:46 right now. So we will be back at 9:56, please. 9:56 a.m. Thank you very much. Okay, I hope you're all back with some chai, etc. So let's jump right into the examples. Okay, so example one is actually pretty straightforward, but it's just highlighting what a free body diagram, reinforcing what a free body diagram is and what a kinetic diagram is. So we've got a crate of mass M, which is being pulled by a cable attached to a trunk. The coefficient of kinetic friction between the crate and the road is mu k. So we got to draw the free body and kinetic diagrams of the crate. That's it. That's about it, right? So remember the three steps. So we first set up our inertial frame of reference or coordinate system. Then we're going to draw the free body diagram with our external forces. And then the kinetic diagram showing just the inertial force vector, which is MA in the direction in which that's going to occur. Right. So free body diagram banane ke liye straightforward. We just draw the block, the crate that we have, and all of the forces, the external forces acting on it. Now, what will be those external forces? It's going to be the weight acting to the center of gravity, the tension in the cable, which is acting at 30 degrees, the normal force exerted on the crate from the ground, and then the frictional force, which is going to oppose motion, and that's why it's going to act to the left. Pretty straightforward. Note that I've just set up my coordinate system, xy like so. Anywhere, origin doesn't really matter right now because my position में इस वक्त interested नहीं हूँ. That's why. Perfect. And then from this, I know okay, the ground is always, the normal force is always going to balance the vertical forces acting on it. That is, मतलब suddenly उसने उछलना कूदना नहीं शुरू कर देना vertical direction में. In the vertical direction, it is going to be in equilibrium. So the only acceleration that it's possible for it to have is because of this truck. So it's going to act in the horizontal direction to the right. So this gives me my kinetic diagram. Okay, so pretty straightforward, as I said. Now let's take a look at a little bit more complicated example of, again, drawing the free body diagram, kinetic diagrams. So we have two blocks, each block with a mass of m. The coefficient of kinetic friction at all surfaces of contact is mu. A horizontal force P is applied to the bottom block. And now we want to draw the free body and kinetic diagrams for each of the blocks. So we'll consider them separately, each block, not of the entire system nahi likha hua, of each block likha hua. So again, we start with our frame of reference, which we're going to fix to the ground. I have our XY coordinate like so. Now let's take a look at block A first. So block A has a force P being applied horizontally to the left. Then of course it's going to have its own weight, which is WAMG. Then it's also going to have a normal force acting on it due to block B. So I'm going to call that NB. और फिर वो जो frictional force होगी इस surface पे, that will be a function of the normal force जो उस surface पे थी. Hence why mu NB. ठीक है, ये थोड़ी सी गलत तरीके से drawn है. This weight should be acting sort of, it is acting through the center of gravity. लेकिन even this normal force should be acting through here, because the normal force also acts through the center of area on which the surface that it's acting on, जो इस case में भी यही होगा. And then similarly we have a normal force acting from the ground on block A, और इस normal force से एक frictional force होगी. Notice कि दोनों की दोनों frictional forces are acting to the right because we have an applied force, external force, जो is acting to the left. If any motion is to occur, it will occur to the left, right? So these two frictional forces must be opposing it, and hence they're to the right. Similarly, for block B, we just have the weight of the block, the tension T in the cable, that's right here, normal force V, जो action, Newton's third law of motion, equal and opposite reaction. तो जो हमने इधर लिखी थी NB, normal reaction force between A and B, वही फोर्स बी पे भी एक्ट करेगी. दैट्स वाई इधर भी आपके पास एन बी ही होगा. एंड दिस टाइम अराउंड फॉर ब्लॉक बी सिमिलरली equal and opposite reaction होना है. तो अगर friction acting on A was to the right, तो ये जो frictional force है acting on block B must be equal and opposite. So that will act at left, towards the left direction. ठीक है जी. Perfect. So we've got that, and then the kinetic diagram of each block. Now, as we can see, B to tension, say, there is a cable attached to it. The tension can keep increasing to resist its motion. So basically, B stays at rest as it is, whereas it's only which might potentially slide. Okay. Two simple examples. The only thing that was complicated in this one was the directions and magnitudes of the reaction forces in between A and B. मतलब ये कि NB दोनों पे act करेगी और frictional force will also be the same but acting in opposite directions. Okay. Now let's look at a quantitative example. So we've got a 400 kg mine car which is being hoisted up the incline, and the force in the cable, this force in the cable is 3200 t squared. The car has an initial velocity of 2 meters per second at t is equals to 0, and we want to find the velocity when t is equals to 2. Okay, interesting. So we know the force, but we want to get to the velocity, which means कि हमें इसके अंदर kinetics के साथ साथ kinematic analysis भी करना पड़ेगा, right? So first of all, we can follow the procedure that we just looked at, which is set up our inertial coordinate system, draw the free body diagram, and the kinetic diagram if we need to, apply the equation of motion, F is equals to ma, summation F is equals to ma, to find its acceleration. Then once we've got the acceleration, then we can use kinematic equations to find the velocity. So this is still pretty straightforward, but that's because I'm just warming you guys up with easy examples, and then from the next one we'll start to jump to ourselves. Now, one thing to notice in this problem is that instead of setting up the coordinate system in our usual way, like so, x, y, it is much easier if we analyze the problem in some sort of a rotated coordinate system like so, where x is acting along the incline and y is acting perpendicular to it. The reason being कि अगर मैं यूं x y करती रहूं, then I'll get force का component in the x y directions, और फिर the resultant force भी I can see कि it has to be up the incline. मतलब it's not going to accelerate up and down like so, right? It's never going to, मतलब वही बात again, it's not going to jump up here like so. There's nothing that's causing that. So the only acceleration that it can potentially have is in the direction of the incline. So either up or down along the incline. So it's much more useful if I just define my frame of reference like that, or my coordinate system like that, ताकि I just get my acceleration just in the x component. Y component mein things will be in equilibrium. Okay, so I will only get my ax. Okay, so in order to do that, then I have my free body diagram like so, with my coordinate system defined like this. So F, the tension is along the incline. Normal reaction force, of course, is normal to the surface, and the weight acts vertically downwards. So agar if this angle is theta right here of the incline, then by trigonometry, and I need someone to help me out because weight को अब मुझे resolve करना होगा, right? So can someone help me out अगर मैं weight को resolve करूं in the direction along and perpendicular to the surface? Let me choose someone. Would someone like to volunteer, or if I pick someone and then they get stuck? and are embarrassed basically. Could you tell me if this is theta, this angle is theta, तो इस weight के triangle के अंदर what would be theta?
मैम वो जो
सेम
कर और जो नॉर्मल के बिल्कुल अपोजिट एक्ट कर रहे हैं उन दोनों के दरमियान एंगल होगा थीटा।
ये वाला
बॉटम कॉर्नर वाला।
बॉटम कॉर्नर वाला ये वाला।
यस
Perfectly right. Okay, you are spot on that this is going to be theta. और again इसकी I think कि ये आप लोग इतनी दफा पहले कर चुके हैं, that's why you're so familiar कि incline के अंदर किस तरह थीटास कहाँ से कहाँ प्रोजेक्ट कर सकते हैं हम. लेकिन if this is unclear to anyone कि why this मैंने इतना घिचपिच करके बना दिया है, this is the weight and इसके ये component है along and perpendicular to the surface, then this is theta. So I'm saying if it's unclear to someone why this is theta, please ask me, okay? And I'll jump through each of these.
Explain कर दे मैम इसको.
Hi. Okay, चले okay. मैं सोचा मैं थोड़ा सा टाइम बचा लूं. Right. Okay. So for that, let's take a look now. ये मेरा incline है, right? और इस incline का ये angle I know is theta, right? Now I have weight which is acting like this. ऐसा ही है, vertically downwards. And what I need is I want कि इसका ये एक parallel to this direction और एक perpendicular to the वो है, ठीक है? और clear like ये बातें clear हो गई. अब देखते हैं, अगर ये थीटा है, मुझे एक और लाइन इधर बनाने दें पैरेलल टू दिस हॉरिजॉन्टल. मतलब ये कि ये वर्टिकल था, इसी का एक और इधर भी बनाने दें ऐसे करके. ये अगर थीटा है तो आई नो कि दिस विल बी थीटा. ऐसा ही है. और फिर इफ दिस इज थीटा और ये जो था ये दिस कंपोनेंट, दिस इज परपेंडिकुलर to this surface, then this angle would be what?
90 minus theta.
90 minus theta, exactly. अगर ये 90 minus theta है, अब आ जाए इस right angle के ऊपर. फिर ये angle क्या हुआ?
Theta.
एक सेकंड. 90 minus theta, right? Because ये 90 minus theta था और ये पूरा एक right angle है. So this is of course then equal to theta. And that's why वो इस triangle के ये inner sort of angle इधर जो bottom corner पे, that's equal to theta. Right. ये clear हुआ या फिर my diagram has made it even more unclear?
मैम ये last step समझा दें.
Last step नहीं समझा. Okay. Let me change the color then. Black. Okay. अच्छा, इधर ये 90 माइनस थीटा तक तो आपको समझ आ गया ना. Why? Because ये दोनों राइट एंगल हैं यूं करके, राइट? सो ये थीटा था, सो दिस इज 90 माइनस थीटा. परफेक्ट. अब आई वांट यू टू लुक एट दिस एंगल व्हिच आई नो इज 90 डिग्रीज इन टोटल. अगर ये पूरा 90 डिग्रीज है और ये 90 माइनस थीटा है, तो ये जो अंदर वाला एंगल है, जस्ट दिस वन, that will be equal to 90 में से subtract कर दें ये वाला. That's why I have 90 में से minus 90 minus theta. ठीक. So when I calculate this 90 minus theta, that's just equal to theta. तो ये angle ये वाला, this angle turns out to be theta. समझ आई?
Yes ma'am.
Perfect. Thank you. Right. So just be careful about this. ये this is the most complicated thing basically इस किस्म की incline problems में, which is के जो incline का angle होता है theta, उसी से हम ये inner angle of the weight पे आते होते हैं हम नीचे वाले, ठीक है? तो just be careful about this. Right. And how do we find theta in this case? I forgot to point out, okay, now we're already given this, the sort of geometric description between, okay, iski cos, sine, tangent, etc. kya hoga? So that's why I can find ke ye theta kya hoga from these values, right? Okay, Bilal, you are saying angle between two lines is the same as the angle between the perpendiculars. Yes, thank you. Okay. Unfortunately, I again am unable to memorize rules and so on. So I like to jump from basics again, unfortunately. So इसलिए मैं ये explanation पे जा रही थी. Right. So for anyone for whom it may still be unclear, please do look at Bilal's take on how to find theta. Because he's completely right. Okay, the angle between two lines is the same as the angle between their perpendiculars. It's a rule. Okay. Now that we've set up the components of weight in the x and the y direction, then I can just find my apply my equation of motion, that is my second law of motion, in the x direction. So if I do that, then I get just acting in the positive x direction. For the weight, I can see that it has a minus component, hence why minus mg sine theta, and this will be equal to max. If I solve this out, I get this expression for the acceleration. Now please remember that we were being asked to find the velocity. So हमें velocity find करनी है. Given that हमारे पास अब एक expression आ गई है for acceleration and time. So these are the three kinematic properties that we need related to each other. मतलब ये है कि हमें कोई वो वाली kinematic equation use करनी है जो इन तीनों को relate करता हो. Which I think I know which one it is. That is, of course, that the acceleration is equals to dv by dt. So this one I can use in the x direction pretty straightforwardly. So if I integrate my expression for acceleration, I will get my velocity. Applying my given initial conditions, which I know कि मेरी initial velocity was 2, और अब मुझे velocity find करनी है time t is equals to 2 seconds. So वो सब कुछ substitute करके apply किया, so I get my answer for the velocity after 2 seconds of the cart. Perfect. Okay. So easy peasy. Now let's jump to you guys doing something. There's too much of me solving problems. So now example 4, I want you all to please take out your pens and papers and your calculators and start to solve this one. This is still a little bit straightforward, like just a little complication कि हमें इसकी free body diagram को जरा ध्यान से बनाइएगा of the elevator. So let's see what the problem is. A freight elevator, including its load, has a mass of 500 kg. It is prevented from rotating due to the smooth track and wheels mounted along its sides. If the motor M develops a constant tension T in its attached cable, मतलब इस एक motor से एक cable की tension given है, it's T. Then we want to determine the velocity of the elevator when it has moved upwards 3 meters starting from rest. Neglect the mass of pulleys and cables. Perfect. Okay, so please everyone start. Our procedure is the same as before. Free body diagram, no, sorry. Coordinate system, inertial coordinate system, free body diagram, kinetic diagram, equation of motion, and then kinematic equations. These 5 steps. Okay, please start. Okay, after I've given you guys about a 1 minute head start, I'm also going to start to solve it here quietly. Okay. Okay, I'm done. Let me see. How's everybody doing here? Excellent. Excellent, Arij. Yes, exactly right. 3.625. 625 it is, yes. 3.64. मोहम्मद मुंजर एक सिर्फ digit off हो गई है लेकिन yes, you guys are all right. Very good. Noor, good. So all of you guys, well done. There was just, I think एक चीज पे थोड़ा सा ज्यादा गौर से सोचना पड़ा था, which is, in my opinion, it was the fact कि इस elevator के ऊपर कितनी tension act करेगी. Now you have to be careful about this one. Please, first of all, remember that if you have a frictionless pulley, then the tension on each side of it is the same, it's T. And also note that it is tension, it is T. तो वो pulley के मतलब इधर से भी उसको नीचे खींच रही है, इधर से भी उसको नीचे खींच रही है, right? Cables are only able to have tensile forces within them. So it will always be, just भी आप किसी attached चीज को देख रहे हैं उससे वो उसको pull ही कर रही होती है cable. So for example, pulley के लिए ये situation थी. So in this case, for my freight elevator, wherever the cable is attached, it's going to be trying to pull it. So over here it's trying to pull it, it's pulling it here, it's pulling it here, it's pulling it here, and so on. And I know कि सब T ही के equal होंगे because these are all frictionless pulleys, such that एक भी pulley के दोनों तरफ you'd get the same tension. So that I have 1, 2, 3, 4 times T acting on the elevator. Right? That was the one main thing to consider. Very good. Good, Shariar. And then the next thing is just to notice that we're in all of this we're getting a case of constant acceleration. So जब मैंने ay निकाला है अपनी acceleration, तो उसकी expression के अंदर सब कुछ constant था. मतलब कि it doesn't really matter what time I'm at, I'm still gonna get the same acceleration, which is why I can use my constant acceleration wali expression. And then I'd written down कि okay, ये constant acceleration है. And then which physical properties am I concerned with? मुझे distance given है कि I've traveled a distance of 3 meters. Acceleration I've found out. And then I'm trying to find the velocity. So I must have one of those kinematic equations जो इन तीनों को relate कर रहा हो for the case of constant acceleration. So I just jumped to directly using that expression. Okay, so straightforward. All right. All right, so now there'll be solution will also be given in the slides. Now let's gear up for a more complicated example. Okay, or let's see what it is first, and then we'll start to do this one. Okay, so abhi we'd considered the case that there were 2 blocks lying on top of each other, और उनका हमने free body diagrams बनाए थे. Now this time around we've got 3 blocks lying on top of each other, and we're looking at this problem. So each of the 3 plates has a mass of 10 kg. If the coefficient of static and kinetic friction at each surface of contact are this, mu s is 0.3 and mu k is 0.2 respectively, determine the acceleration of each plate when the 3 horizontal forces are applied. Okay, over 3 horizontal forces, so तीनों का mass 10 kg है, mu k is 0.2, mu s is 0.3. And now FB is given to be 15 newtons. FC is equals to 100 newtons. And FD is equals to 18 newtons. Okay, so this is the problem that we are now looking at, and we have to find the acceleration of each of these. Okay. I'm gonna give you guys a little while to think about it. I just want to let you know that this is quite a difficult problem. Kal we had our class with 11. This is 11D with 11C, or I got stuck on this problem so terribly that I'm still not so sure that I've got it completely clear in my head. So I will need your help to solve this one. Okay. So please have a moment to think about it yourselves, and then start as well.
एक्सक्यूज मी मैम, पहले इसमें ये भी डिटरमिन करेंगे ना कि फ्रिक्शनल फोर्सेस की वजह से क्या ब्लॉक्स मूव भी करते हैं या नहीं?
Noor, बिल्कुल, you're completely right. Yes. Yes. Because what Noor is implying is that, as you all may recall, frictional forces, there is not a fixed force which has just one value. It can change, right? So basically, it has a maximum value that we know of. So we have to see first कि जो किसी भी block पे applied force है, let's say कि FD के ऊपर 18 Newton है, is it even greater than the frictional forces or not? क्योंकि अगर वो greater नहीं होगा तो फिर अगर frictional forces ही इतनी ज़्यादा हैं तो फिर the block may not move. Also, one more thing that I would like you guys to think about is that it's one thing to start immediately to look at each of the blocks separately. और फिर it's another thing कि आप पहले पूरे system को as a whole treat करें. ये दो approaches अलग-अलग भी apply की जा सकती हैं. So for example, either I could start just by looking at block B, or I could initially start by looking at the entirety of the thing. Okay, I'm going to give you guys a few more minutes. And then I'm going to start with the problem as well. Talha, I don't know how you've done it so quickly, but yes, it is. You're right. Okay, please, how are you getting on? Any other results? No, Hamza. Sorry, this one is incorrect. Apologies. Talha, not quite. Not quite. Not quite, Numan. So acceleration of D जो value है वो तलहा ने जो दी है वो correct है, लेकिन अभी हम discuss करना शुरू करेंगे तो we'll see कि I'm a bit uncomfortable with this solution, so let's see. Okay, shall I start? Arij, good one. This is another reasonable answer. And I'm not so sure what the actual right answer is. So I think it's time that we do start the discussion. Okay. So when when I start the discussion, I do need all of you to come back. So please, जब आप लोग satisfied हो कि you've made a reasonable attempt at it, then let me know and I'll start basically, because I'm telling you I need your help for it, right?
एक्सक्यूज मी मैम
हाँ जी.
मैम अगर मुझे सॉल्यूशन का बिल्कुल आइडिया ना हो और अगर मैंने चैट में आपको कोई आंसर ना दिया हो तो कोई प्रॉब्लम तो नहीं है?
क्या मतलब है इसका?
मुझे इस क्वेश्चन का सॉल्यूशन का बिल्कुल भी आइडिया नहीं है.
अच्छा. ठीक है हमजा, लेकिन ऐसे तो नहीं, कुछ तो ट्राई करना चाहिए हमेशा, नहीं? आपने
मैम मेरा वो फ्रिक्शन का टॉपिक थोड़ा वीक है.
ओके, चले हमजा. अभी तो मतलब मैं आपसे ये नहीं कह रही कि कोई वो मसला होगा, लेकिन हमेशा कुछ ना कुछ तो एफर्ट करनी चाहिए, राइट? सो इसलिए
यस मैम.
प्लीज जस्ट इवन फ्री बॉडी डायग्राम तक की भी एफर्ट अगर करें तो थोड़ी सी चीजें तो उससे स्टार्ट हो जाएंगी ना क्लियर होना. चलें, नो प्रॉब्लम. आपकी अंडरस्टैंडिंग में कोई इशू नहीं होगा, लेकिन जस्ट फॉर योर ओन सेल्फ यू शुड मेक एन एफर्ट, राइट? फॉर एवरीबडी एल्स, लेट मी नो. Arij, Numan, Hamza, should I start? Yeah, do you want to still carry on with your solution a little bit longer? तला अभी भी थोड़ा सा गलत है. थैंक यू आरिज. ओके नुमान, आपका माइक स्टिल नॉट कम्प्लीटली वर्किंग फाइन, बट ओके आरिज ने कहा है कि शुरू करें तो आई एम गोना स्टार्ट. राइट, पहले तो व्हाट आई वांट यू गाइस टू हेल्प मी आउट विद इज कि शुड आई स्टार्ट विद बी और शुड आई स्टार्ट फ्रॉम द टॉप? Does anyone have any suggestions for that?
Top.
Why top? I actually think that it may be better to start from the base. The reason being because I don't know what's happening relative in between these now, right? मतलब ये कि मुझे ये नहीं पता कि C ने मूव करना है या नहीं करना, तो फिर मुझे ये कैसे पता चलेगा कि D और C के दरमियान में किस किस्म का relative motion हो रहा है? So I want to start just by looking, at least मुझे जो दिमाग में आ रहा है, मुझे ये concern है कि I want to start by looking first कि whether B, मतलब ये कि जो सबसे बेस पे है वो क्या ग्राउंड के रिलेटिव स्लाइड कर रहा है या नहीं कर रहा. अब उसके लिए I can start with two ways basically. One way is कि मैं पहले सिर्फ अभी मुझे भी I know कि मेरी अगर explanation completely clear ना हो तो थोड़ा सा please forgive me. And help me out to clarify it as well. But let me start with B and consider first just the free body diagram of just B. जस्ट बी पे मैं देख रही हूँ पहले, सिर्फ बी. अब I know for B I have an FB. Actually, sorry, apologies. My coordinate system is fixed to the ground and is like so, XY. So in the negative x direction, I have a force of 15 newtons acting. And then I know कि B के ऊपर और क्या अलग forces act करेंगे. One is that it has a mass of, it has a weight, it has a weight of mg. ठीक है जी. दूसरा ये I also know कि it has a normal force acting on it from the two blocks C and D. और C D की तरफ से उसके ऊपर क्या normal force act कर रही होगी? That will be equal to their weight. So it's 2 mg acting on it. ऐसा ही है. तो अब अगर 2 mg इस सरफेस के ऊपर नॉर्मल रिएक्शन फोर्स एक्ट कर रही है, तो जो फ्रिक्शनल फोर्स है, एक तो ये कि क्लियरली ब्लॉक के ऊपर 15 न्यूटन्स टू द लेफ्ट फोर्स अप्लाई की जा रही है. तो अगर उसने मूव करना था, देन इट वुड मूव टू द लेफ्ट, which means कि frictional force will be opposing that motion and will be acting to the right like so. अब इस frictional force का magnitude क्या होगा? Frictional force is always F is equals to mu times the normal force that's causing it, right? So it would be, normal force क्या है? 2 mg times mu. अब पहले मैं अभी ना सिर्फ mu लिख रही हूँ, just because I don't know yet कि whether it's going to be static or kinetic or what exactly is it going to be. Okay, so let's leave this like so. Next, I also have the lower surface acting right here. So इस lower surface के ऊपर normal force, of course, क्योंकि it is in equilibrium in the vertical direction. So this normal force must balance this 2 mg and this mg acting downwards. So this normal reaction force is going to be equal to 3 mg. Everybody following so far? Now, इस normal force की वजह से जो friction आएगी, वो भी again oppose motion करे, it will oppose motion, and it's going to be this normal force times mu. So it's going to be 3 mg times mu. Okay. So with this, I know अहमद है या अब्दुल्ला है, मैं इसीलिए ना, नहीं आरिज है, आरिज बिल्कुल आरिज, इसीलिए ना मैं अभी दूसरा वाला केस भी कंसिडर करने लगी हूँ, क्योंकि मुझे इस चीज का श्योरिटी नहीं है whether B and C are moving relative to each other or not. So for example, only अगर B C के relative move करेगा तो फिर यहाँ पे ये friction force होगी ना. ठीक है, तो दूसरा केस भी है मेरे पास, which I'm just going to consider in one moment. पहला, this is the case, sort of case 1, when there is sliding between B and C. तब हमारे पास ये केस होगा. ठीक है, तो इस केस में let's just see कि does B move or not. ठीक है, अगर हम assume करें कि C तो move कर ही रहा है, let's first assume that. ठीक है जी. So in this case, what is the maximum friction that I can get? Going to be F max, which is what? Maximum friction is the case when I have static friction between the top and the bottom one as well. ठीक है, मैं पहले जरा एक F max करके देख लेती हूँ, which is 5 mg mu s, and that turns out to be how much? If someone could please let me know. 5 times
490.
Sorry,
490.
490 तो नहीं आ रहा मेरे पास, तो 147.15 आ रहा है.
Oh, sorry.
Check 5 mg, right? M is just 10 and 9.8. So this is the case when I'm assuming कि दोनों upper और bottom surface पे mu s हो. लेकिन again what if even if I consider F min, that is I'm already saying कि C जो है वो move C पे sliding हो रही है और maybe ये B और A पे ना हो रही हो, so थोड़ा सा मैं इसका अगर F min भी ले लूँ, थोड़ा सा फर्क version, which is to assume कि 2mg जो है mu k हो, mu k because it's sliding, plus 3mg mu s हो, तो फिर क्या आता है मेरे पास? Still then, what does F min turn out to be? Anyone? I think it's 127.5 newtons. So even for the case जब मैं assume करूँ कि मतलब स्लाइडिंग को assume करते हुए लेकिन ऑलरेडी के मूवमेंट जब हो रही हो तब भी, तो फॉर बोथ ऑफ दीज केसेस एक्चुअली तो आई थिंक मुझे सिर्फ एफ मैक्स ही लेना चाहिए, लेकिन स्टिल जस्ट अज्यूम के दूसरा वाला केस भी मैंने ले लिया, देन आई कैन सी कि
मैम
हाँ जी
मैम ये यूके क्यों नहीं आया यूएस से?
कौन सा नीचे वाला
वाला ऊपर
नीचे
वाला
ऊपर वाला
ऊपर वाला, क्योंकि मैम स्लाइड जब करते हैं तो हम काइनेटिक फ्रिक्शन लेते हैं।
मैंने इसीलिए यूके डाला है, ये एफ मिन दूसरे एफ में कैलकुलेट करने के लिए मैंने म्यू के ही लिया है ऊपर वाले को, 2mg म्यू के लिया है जस्ट टू चेक कि इन केस मेरी फ्रिक्शन सबसे मैक्सिमम ना हो, उससे कम भी हो अगर। क्लियर हो गया? जो पूछ रहा था फिर आप बाद में बताते ही नहीं है कि क्लियर हुआ है या नहीं। हेलो हेलो हेलो
मैम आप सॉल्व कर रहे हैं फिर पूछते हैं।
नहीं ये वाली बात तो पहले बताए ना, ये वाला पार्ट क्लियर हुआ कि यू वर सेइंग कि अगर
Yes, ma'am.
स्लाइडिंग हो। हाँ ओके ठीक है। तो अब व्हाट आई वांट यू गाइस टू नोटिस इज कि बोथ ऑफ दीज, ये वर्स्ट केस सिनेरियो और उससे थोड़ा सा कम बुरा सिनेरियो, दोनों केसेस में whatever we do in this case, F is much greater than 15 newtons. It's much greater than FB जो 15 थी। So मतलब ये है कि ये 15 न्यूटन वाली फोर्स तो जो भी हो जाए, it is always going to be overcome by the friction force, या it will be balanced. So A के अंदर अगर हम फोर्स बैलेंस करेंगे, which of course means F minus FB, right? क्योंकि friction is to the right minus FB which is to the left, then ये हमेशा friction force से balance हो जाएगा FB, such that this means के AB is not going, there is going to be no resultant force on B. So AB is going to be equal to 0. Now I know that when I was doing this analysis, I'd assumed that there is sliding between B and C. So मैं इसीलिए ना, just to be very careful, I'm going to try out my second case as well, which is going to be case 2, where I'm going to check that there is no sliding between B and C. और सच दैट अभी क्योंकि मैं बी को देख रही हूँ तो मैं ऐसे अज्यूम करती हूँ कि ये पूरा का पूरा सिस्टम ही टुगेदर है। आई जस्ट अज्यूम कि देयर इज नो स्लाइडिंग बिटवीन एनी ऑफ देम। When there's no sliding between any of them, then I'm looking at the entire actually no sliding between B, C and D करना पड़ेगा। किसी में भी स्लाइडिंग नहीं है, वो पूरा का पूरा moves as one whole block, just a second case का चेक करने के लिए। Then in that case, what I get is that I have a force Fc of 100 newtons, and then an Fd of how much? 18 newtons, and then a force of 15 newtons acting to the left. Here I have a combined weight of all of them acting, which is going to be 3 mg, which then means that there will be a normal reaction force of 3 mg, And finally, a friction force which will oppose motion, or oppose motion कैसे किस direction में होगा? Clearly, this force to the right is larger than the two forces on the left. So if motion was to occur, it would occur to the right, which is why I'll get my friction force in this direction. So this will be my phone is going off because I'm guessing many people are comment. Can't write here, sorry. So I'll just write it here. 3mg mu. Many people are commenting. Okay. So abhi aapas mein discussion. That's okay. So let's come back to this one. Friction force to the left. Now in this case, ये मेरा case 2 चल रहा है. In this case, my F max is just equals to 3 mg mu s, which is what? 3 times 10 times 9.81 times 0.3. It's 88.3 newtons. Or what is my F to the right? Because of the applied forces, it's 100 minus 15 minus 18, which is how much? 67. So again, I see okay, my friction force, even if I assume no sliding, my friction force is still greater than my applied force. है ना? So even in this case, अगर मैं no sliding भी assume करती तो तब भी I would have got that AB is equals to 0. ठीक? How is everybody doing so far? So for B, we're sure that whether we assume there's sliding or whether we assume there's no sliding between the top, उसके ऊपर वाले जो blocks हैं, B की acceleration just comes out to be 0. Okay? This case is the best case scenario. It was most likely to slide or not. Or whereas this one is the worst case scenario. मतलब ये जब friction सबसे ज़्यादा largest है थी. So इसमें friction was largest here. Here friction is the least. ये जो इसमें F max calculate किया. Okay. Okay, so we're clear so far that B is definitely not moving. ये बात and no comments, so I'm guessing this part is clear. Okay. Now let's move to C and D. Can I erase this, all of this? मैंने वो C और D पे नहीं लिखा. चलें, I'll start. Now let's consider block C and D. So B is not moving. Now for C, I want to do the same thing, which is I want to consider its case 1, which is assuming that there is sliding between C and D, and then a case 2, जिसके अंदर there is no sliding between C and D. Okay, so let's start with that. If मैं sliding consider कर रही हूँ, then I'm just considering C on its own. इसके ऊपर there's a force of 100 newtons, and then let's think about what the other vertical forces acting on it are. So there's a weight of this thing, mg. Then there's the weight of D acting on top of it, mg. So इस normal force की वजह से there will be a friction to the left of mg mu. Now the normal reaction from block B जो नीचे था, उसकी वजह से हो जाएगा 2 mg because it has to balance both of these. So you 2 mg आ गया. Now because of this normal force, we will get a force of 2 mg mu. right? So in this case, my F max is, if I assume कि ये सब kinetic है, sorry, सब क्या है? सब static है, yes. 3 mg mu s, which turns out to be 88.3 newtons. Now this F max, when I'm assuming that all of the friction की maximum value है, जब sliding हो भी रही है C और D के दरमियान में, उस केस में this F max is less than the applied force FC, right? Which means that FC will overcome the friction such that when I have my delta summation F is equals to MA, I get that 100 minus 88.3 is equals to M कितना है इसका 10A. So और ये A is acceleration of C such that AC turns out to be I think I've made a mistake. What does AC turn out to be? Could someone help me out? तो कुछ गलत लग रहा है मुझे इसमें. कोई भी है उधर behind the screens?
1.1.
Oh, sorry, मैं भूल गई एक बात. Apologies. Sorry. So F max was mu s, right? It was 88.3. लेकिन once motion starts, that is once I get my acceleration, फिर तो it will not be F max, right? It will be 3 mg mu k. Yes, sorry, मैं ये part भूल गई थी. मैंने वो directly लिख दिया था, but once motion starts, it should be mu k. So I do need to readjust for it. And when I calculate that, फिर my acceleration comes out to be 4.114 meter per second square. To the right. So this is the case when I'm assuming that there is sliding between C and D. Let me assume that there is no sliding between C and D. And if there's no sliding between C and D, then they move together as one, such that then I have a force of 100 newtons to the right, 18 newton to the left, total weight acting downwards of 2 mg, reaction force also of 2 mg, frictional force again, ये 100 newton ज़्यादा बड़ी है left वाली से, तो frictional force will oppose that and it will go to the left and it will be 2 mg mu. All good? बस इतना ही है ना? So when I calculate F max in this case, it's going to be 2 mg mu s. So that turns out to be, अगर 3 mg less था तो 2 mg तो definitely less होगा ही ना. This is certainly going to be, नहीं वो 100 minus वो भी था, sorry. So इसलिए ये check करना ही पड़ेगा. 2 times 9.9. It's 58.86 newtons. I have like 4 minutes. आप लोगों की कोई class नहीं है इसके बाद, okay? So I can carry on for a little bit longer. And then F to the right जो है, that I have is 100 minus 18, which is how much? 82 newtons. So again, friction जो है, it's turning out to be less than the applied force. मतलब ये कि अगर मैं no sliding भी assume करूं, तब भी I would get कि this entire thing will have to, what's the word? It will have an acceleration. So in this case, if I have summation F is equals to MA, then what do I get? AD2 minus 2 mg now mu k, right? 82 force थी to the right और friction है 2 mg, लेकिन अब क्योंकि movement होएगी, motion है, that's why it's going to be mu k. This is going to be equal to the mass of all of this, which is what? 2m. दोनों के दोनों साथ move कर रहे हैं, I'm assuming. So 2ma, और ये इसको मैं ना cd लिख देती हूँ because वो दोनों का साथ होता है. So ACD is going to be then 2.138. ठीक है जी. Okay, so now we're getting two different accelerations for basically C, right? Or एक case है when we're assuming that there is sliding between CD, और एक case है when we're assuming that there's no sliding between C and D. ऐसा ही है? अभी तक is everybody following what I'm doing? Yeah, I've already lost you guys.
Following, ma'am.
नहीं मतलब
नहीं, फॉलोइंग कर रहे हैं मैम.
परफेक्ट, थैंक यू. तो अब मुझे ये बताएं कि हमें कैसे पता है कि ये होनी है एक्सेलरेशन या ये केस होना है? How do we figure that part out? So for that, I'm guessing that we need to move to block D. और अब block D के लिए हमें यही दोनों केसेस देखने पड़ेंगे, which is case 1 sliding between C and D and case 2 no sliding, क्योंकि इसको एनालाइज करके हमें शायद पता चल जाए कि which case was actually coming out to be true. So when there is sliding between C and D, then what am I getting? I've got my block D, or it has a force of 18 Newton acting this way. This is FD. It just has a weight of mg, जिसका मतलब there's just going to be a normal force of mg. और frictional force कहाँ act करेगी? To oppose the motion of D when there is sliding, right? So it's going to be acting in this direction. पीछे भी यही किया होगा हमने, please देख लें. Right here, it's mg mu to the left है अगर C के ऊपर, तो D के ऊपर वो ही mg mu to the right होनी चाहिए. Perfect. Okay. So what is F max in this case? Friction max. Friction max is अगर sliding हो रही है already, मतलब ये कि अगर C already move कर रहा है, तो इस केस में I don't even think मुझे mu s नहीं लगाना चाहिए, मुझे सीधा ही क्या लगाना चाहिए? mu k लगाना चाहिए. तो वो slide कर रहे हैं. Maybe. I'm not too sure about this, but let me see. मैं mu k करके try कर लेती हूँ, mu k. And I get what? 10 into 9.81 into 0.2. And I get a value of 19.6 newtons. And this F, क्योंकि मैं कह रही थी ना कि C तो move कर रहा है sliding जब हमने assume किया है. So this is going to exist. So ये F max जो है, this is larger than the FD जो apply हो रही थी, which was 18 newtons. तो मतलब ये कि actually ये friction जो है वो जो right की तरफ act कर रही है, that is larger. So in this case अगर मैं summation F is equals to MAD निकालूं, then I'm getting that a frictional force to the right of 19.6 newtons. Now notice I've used mu k because I've assumed कि sliding हो रही है C और D के दरमियान में. So I'm already assuming कि इस motion की C के motion की वजह से D पे ये force act कर रही है. So 19.6 minus 18 is equals to MAD, which gives me that AD is equals to 0.0 162 meter per second square to the right. So if I assume sliding, this is what I'm getting. अभी भी I'm still not 100% sure कि sliding हो रही है या नहीं. ये तो उसी assumption के साथ चल रहा था ना. अभी confirmation मेरे पास नहीं आई, लेकिन at least case 1 जो है, it's working through it. अभी तक उसमें कोई sort of inconsistency नहीं आई. तो इसलिए जी प्लीज.
मैम ये एफ मैक्स अप्लाइड फोर्स से कम है तो फिर तो ये स्टैटिक नहीं होगा.
एफ मैक्स जो है वो अप्लाइड फोर्स से लार्जर है. अप्लाइड फोर्स इज 18 न्यूटन्स.
सॉरी मैम, वही कि फिर अगर वो फ्रिक्शनल फोर्स हमारे पास ज्यादा है, अप्लाइड फोर्स कम है, तब तो बॉडी मूव नहीं करेगी.
बिल्कुल, आई गेट योर पॉइंट. लेकिन हो ये रहा है कि सी जो है ना वो मूव कर रहा है टू द राइट. ठीक, मतलब ये कि ये जो ये म्यू के है, दिस इज कमिंग इनटू इफेक्ट.
यस मैम.
सो द पॉइंट बीइंग के जो फोर्स बिटवीन सी एंड डी है, बिकॉज ऑफ द मोशन ऑफ सी, वो अपनी मैक्सिमम वैल्यू पे पहुंच रही है. ताकि it's not just going to be equal to the applied force, it's actually going to exceed it. Noor? So C और D के motion की वजह से वो पूरी की पूरी frictional force has come into effect.
Okay.
Such that even D के ऊपर भी वो act कर रही है to the right. Right? I know what you're saying कि आमतौर पे जब कोई चीज यूं है एक्ट कर रही है और उसके ऊपर आप कोई फोर्स अप्लाई कर रहे हो, तो फ्रिक्शनल फोर्स जिस अगर आप पहले 1 न्यूटन थी तो फ्रिक्शनल फोर्स विल जस्ट बैलेंस दिस. फिर जब वो ये 2 न्यूटन हो गई तब वो फ्रिक्शनल फोर्स इज जस्ट गोइंग टू बैलेंस इट. दैट्स व्हाट you're saying, right?
Yes ma'am.
Such that eventually it will reach its F max only अगर ये भी उतना ही हो. लेकिन इस केस में ना from what I'm understanding, or again I must admit कि I have looked at the solution beforehand, इसीलिए I'm also a little bit forcing myself to accept this, and it is a little uncomfortable for me to understand कि frictional force already ही अपने max value पे ही act करेगी on D, but it seems to me कि because C is already moving, C move कर रहा है, right? So because of the motion of between C and D, ये frictional force has come into effect in its जो mu k वाली version है, because of its motion. ठीक है जी? And that's why इस D के ऊपर वो पूरी की पूरी as it is in terms of kinetic friction act कर रही है to the right. And the only thing that's ending up happening is कि अभी मैं थोड़ा सा सिर्फ ये देखिएगा जरा कि केस 1 के अंदर ही C की acceleration was to the right, but it was much larger. तो D के साथ क्या हुआ है? D के साथ ये हुआ है कि ये जो 18 न्यूटन की फोर्स उसके ऊपर एक्ट कर रही थी, that's basically preventing it from traveling along with C. अगर इमेजिन करें ना इसके ऊपर कोई फोर्स ना होती तो फिर ये D और C दोनों जाहिर है साथ ही मूव कर.
ठीक है. Right, I get it now.
Yes. So just look carefully here कि D का acceleration छोटा हो गया है from C. So C moves quicker to the right, whereas because D had this force acting on it, so D is still moving. It's still moving to the right because of the motion of C, but at a much lower acceleration, such that there is sliding between them. Okay. I know a little uncomfortable, but abhi with this example, this is not the end. We have to all of us have to go back and re-look at this solution to understand it more thoroughly. अच्छा, अभी भी still I don't know कि sliding है या नहीं, so I do need to look at case 2. So let me jump to case 2 a little quickly. एक second, sorry, I had a meeting at 11, so let me just tell them कि I'm going to be a little late. So आप लोग no sliding वाला case जरा please try करें. What does no sliding mean? No sliding means के acceleration of D must be the same as ACD, है ना? So think about that while I just let people know. और ACD था क्या ये भी, sorry, I should probably write that down. It was 2.138.
मैम क्लास खत्म हो गई है?
नहीं, मैंने कहा है आपको, ये देखा, ये इसका मतलब ये पहले सुन ही नहीं रहे थे जो भी। मैं आपको कहा है कि मैं 1 सेकंड जरा बता के आ रही हूँ कि मेरी ये क्लास ओवर रन कर रही है, तो मैं अपनी मीटिंग में लेट हूँ, तो आप लोग तब तक ये नो स्लाइडिंग वाला करें। अच्छा, एनीवे, मैंने बता दिया इसलिए आई एम बैक। So the point is that when there is no sliding, then C and D will have the same acceleration जो अभी हमने पीछे कैलकुलेट की थी। और अगर मैं खाली D का वो बनाऊं फ्री बॉडी डायग्राम, then I have that this is equals to 18 newtons, और इसका mass is going to be mg, weight is going to be mg, और there has to be, अगर D और C को साथ चलना है, so there are two ways to think about this. So that means that they are static with respect to each other, right? मतलब ये कि C और D आपस में मूव नहीं कर रहे, which means कि उन दोनों के दरमियान में static friction act करेगी। फिर ऐसा ही है। Static friction just exists in general, right? Maximum value के साथ, अगर कोई और चीज अप्लाई हो रही हो। तो अगर if I have that, इधर मुझे mg mu k था when there was sliding, and here I have mg mu s। एक तो ये तरीका है, ठीक है। दूसरा तरीका ये है कि I could assume कि अगर there has to be no sliding between them, तो फिर भी what friction force do we require ताकि इन दोनों के दरम्यान में sliding ना हो। I'll try this out पहले के, just assume कि mg mu s है, और इसकी वजह से क्या हमारे पास वही acceleration आती है या नहीं। So in this case I have my F max, which is mg mu s, no relative sliding. So I get, what do I get? 9/1 into 0.3. I get a frictional F max of 29.43. ऐसा ही है। अब 29.43, which means कि I can apply, again, this is greater than 18 newtons, so sure, that mean it will cause an acceleration to the right. Perfect. But let's see, okay, what is the acceleration that it causes? It causes F max minus 18, वो जो ये लेफ्ट पैक करिए, is equals to MAD. So AD आ जाता है इससे क्या, 29.43 minus 18 divided by 10. So AD आ जाता है, sorry, 1.143 meter per second square. And this is, ये AD मतलब अगर मेरे पास maximum friction भी act करे ना between C and D, जब no sliding हो, तो तब भी I am getting an acceleration which has this value, but this is not equal to the combined acceleration of CD जो मैंने पहले calculate की थी. This is not equal to ACD. मतलब ये कि this static friction is not enough to keep C and D stuck together. It does not lead to D having the same acceleration as C, such that this case does not, मतलब ये कि actually there is sliding. वो आपस में साथ चिपके नहीं रह सकते।
मैम
जी
मैम यहाँ पे हम फ्रिक्शन को एज एन अप्लाइड फोर्स कंसीडर कर रहे हैं क्या? क्योंकि सी एंड डी जब नॉन स्लाइडिंग होंगे।
जब C और D नॉन स्लाइडिंग है तो उन दोनों के दरमियान में स्टैटिक फ्रिक्शन एक्ट कर रही होगी, बिकॉज द रीजन बीइंग कि D के ऊपर एक अप्लाइड फोर्स है ना, so this is trying to cause motion and we are saying कि ये जो what this is trying to cause a motion of, this frictional force is going to try to resist it.
मैम लेकिन ये रेजिस्ट नहीं है, ये तो मोशन कॉज कर रही है ना 29.43, तो ये फ्रिक्शन यहाँ पे काइंड ऑफ अप्लाइड फोर्स का काम कर रही है
Fair
क्योंकि
point.
सी इज मूविंग।
Yes, because C is moving. Yes, you're right. Yes, it's acting like an applied force on D. बिल्कुल ठीक
ओके
है, ठीक है। Because C is moving. ठीक है, बिल्कुल ठीक है, ऐसे ऐसे सोच लें, right? लेकिन we do know कि वो friction की value क्या होगी, right? Because when it's not sliding, फिर इसका मतलब the maximum value that it can take is this mg mu s आपस में। So when I use that static friction, it turns out कि D का acceleration की जो value आती है, that is less than the total acceleration of C and D taken together, which means कि this friction is not enough to keep D stuck onto C, and instead actually क्या होगा कि there will be sliding between them, और अगर sliding हो रही है तो फिर we jump to our case 1, which means कि case 1 was the true case, that's what's going to happen physically, or our accelerations of each of these separate blocks then turns out to be कि AD की ये acceleration होगी to the right, लेकिन much less than the acceleration of C to the right, जो कि it's much larger। ठीक है जी, so I hope it's a little bit clear. Again, as I said, if things are not clear right now, all of us have to go back and take a look at it in much more detail ourselves. ठीक है जी, so if you have any more questions right now, please ask. You can otherwise go over the recording and think about it again. Think about it again.
मैम फाइनल आंसर में यही लिखेंगे ना जो स्लाइडिंग वाली है?
बिल्कुल स्लाइडिंग हो रही है, दिस इज द ट्रू, ये
सी
दिस
और
इज
डी दोनों में।
जी, ए डी की ये एक्सेलरेशन है और ए सी की ये एक्सेलरेशन है।
ओके मैम।
ओके, ठीक है जी, सो दैट्स इट फॉर टुडे। Next week inshallah we'll pick up with I think there's sorry इसकी solution आ जाएगी, there's just one more example that I want to do for there's one more example that I'd like to do, but I will pick that up later next time. So until then, please take care, and that's it from me, right?
मैम
हाँ जी,
मैम ये मिड में तो
मैम
नहीं आएगा?
एक एक करके बोलें, I don't understand what you're